The second example that I'd like to look at in the area of rational functions involves just doing partial fractions. And it's a slightly more complicated partial fraction than the one we just looked at. So let's write, here's this problem here. It is going to be 4x squared minus 9x plus 5 divided by 2x cubed minus 11x squared plus 20x minus 12. Oh boy. Okay, so we're trying to simplify this into its partial fractions, and the reason we might be doing this, of course, is the same reason that we had before. We might be trying to integrate it. So we need to look at the denominator and see what we can do with that. So let's look at the denominator first. Well, this 2x cubed minus 11x squared and so on is a fairly complicated looking function, and we want to try and factor it. Now, if you're very swift, you might look at that and immediately spot how to factor it, but I'm not that swift, so I'll just take a slightly more mundane approach to it. And what you might hope when you've got a cubic like this is you might hope that it has some factors that involve integers. So let's look for integer values of x that make the denominator equal to 0. So look for integer x such that the denominator is equal to 0. Okay, well, let's write down a few values of x, and in fact, since we're doing this, we might as well plot that function there, since we're going to be calculating values of x here. So let's say x is say 0, 1, 2, 3. Okay, so if x is 0, there's the denominator. If x is 0, then the denominator is minus 12. So if this is x, well, here is x equals 0, denominator is minus 12. If x is 1, then the denominator is 2 minus 11, which is minus 9, plus 20, which is 11, minus 12, which is minus 1. So if x here is 1, we're also going to do 2 and 3. We're down here, just below the axis at minus 1. If x is 2, we've got 2 times x cubed. So it's 2 times 8, 16. Might as well keep track of it here. 16 minus 11 times 4. So that's minus 44 plus 20 times 2. So that's plus 40 minus 12. So, well, that bit in the middle, 44, minus 44 plus 40 is the same as minus 4. 16 minus 4 minus 12 is 0. So there we are. We've got the root that we might be looking for. So there is a 0. And x equals 3, we might as well do it since we can, if we do it, we can sketch this graph. That number there is 20, so 2 times 27 is 54, minus 99 plus 60, and then minus 12. And when I did that one before, I got a positive number, which is up here somewhere. You can work out what it is fairly easily. And so you've got an idea of what this cubic function looks like. So I'll just write down a positive number. And so it goes sort of up here, and then, in fact, it's not completely clear what goes on here. We'll leave that bit in the middle blank for a moment, and certainly it goes up like that. We do know that in the end it's 2x cubed. So as x becomes very large and positive, it's going to keep on going up. And as x is negative, large and negative, it's going to keep on going down. So it's going to be something like this. And I'm going to leave that bit in the middle blank for just a moment. So we're going to look, we now know that x equals 2 is a factor of that cubic equation. So we need to work out, so it's a cubic, x minus 2 will be a factor. We're left with a quadratic factor for the other part. So let's work out what the quadratic factor is by dividing these polynomials. We've got 2x cubed minus 11x squared plus 20x minus 12, and we're going to divide that by x minus 2. So how many x minus 2's do we need to balance the 2x cubed here? Well, we need 2x squareds of them. So because 2x squared times x is the same as 2x cubed. So if we take that x minus 2 and we multiply it by 2x squared, we get 2x cubed minus 4x squared. And now we subtract. This is just long division for rational functions. We subtract, so the 2x cubed and the 2x cubed cancel. The minus 11x squared, and now minus is plus 4x squared gives us minus 7x squared. We bring down the 20x from here, and we ask, well, how many x minus 2's do we need to balance this part? So the top, what we need here is going to be 7x, right? Because 7x times x is minus 7x squared. Sorry, minus 7x times x is minus 7x squared. Multiply this together, we get minus 7x squared plus, well, it's minus 7 times minus 2, so it's plus 14 x. And now we are subtracting these two. Minus 7x squared minus 7x squared is 0. 20x minus 14x is 6x. We bring down the minus 12 from up here, and we say, all right, well, how many of these do we need to balance that 6x? We need 6 of them. So it's plus 6 here. We take that and we multiply by 6. That becomes 6x minus 12. And when we subtract that, we get 0. So that tells us that the remainder here is 0 when we divide this cubic by x minus 2. And this is then the quadratic fraction. So our cubic here is x minus 2 times 2x squared minus 7x plus 6. So that is x minus 2 times this is the denominator. Okay, so having worked that out, we've now got the denominator looking a little bit nicer. Okay, so we need to factor this quadratic. And by curious coincidence, this quadratic here is the same as one of the quadratics that we looked at earlier. So this is the x minus 2 stays here, and this is, we've already factored it. It is x minus 2 times 2x minus 3. So that, let's just check that that's true. We've got x times 2x is 2x squared. The minus 2 times minus 3 is plus 6. The minus 2 times 2x is minus 4x, minus another 3x is minus 7x. So that is worked out correctly. So in fact, we could write this as, say, 2x minus 3 times x minus 2 squared. Okay, so we've managed to factor our cubic. And having done that, we can actually complete this graph here, because we now know that this cubic function is 0 when this factor here is 0 as well, right? So x is 3/2, halfway in between here. So our cubic function goes through the axis here, and it is x minus 2 squared, which means it just touches the axis when x is equal to 2. So it goes up, down, and then down a little bit, and then up again. So we've got a little bit of a wiggle here in the middle between x is 3/2 and x equals 2. That's just by the by, so that we can understand what this cubic looks like. All right, now we are now in a position to start thinking about partial fractions. So this fraction up here is supposed to be written in terms of these components, right? So the denominator here is made up of two factors, the 2x minus 3 and this x minus 2 squared. So x minus 2 squared. Okay, what do we put? Having written that up there, we can now erase all of this. So with partial fractions, you put in the numerator a polynomial of 1 degree less than the denominator. So if this is a first degree polynomial, 2x minus 3, power here is 1. We need just a constant on top. And this thing here is a second degree polynomial. There'll be an x squared there. So we need something with a bx plus c. It's not the only way you can do it. You can also write this as something over x minus 2 and some constant over x minus 2 and another constant over x minus 2 squared. They're equivalent. All right. So we need now to choose a, b, and c to make everything work. All right. So the way we proceed is, as with all partial fractions problems, you put everything back over a common denominator, and then you try and choose a, b, and c, so that the polynomial here on the left is going to be the same as the one on the right. So that is a times x minus 2 squared plus bx plus c times 2x minus 3, all divided by 2x minus 3 times x minus 2 squared. The denominators are the same. That's how we got this here. So the numerators also have to be the same. And not just the same, they have to be identical for all values of x. That means the coefficient of x squared, x, and the constant have to be the same on both sides. So to work out what the coefficients are, let's expand things here. So that is a times x minus 2 squared. So x squared minus 4x plus 4. It's x minus 2 squared. And let's expand that out as well. There's a bx plus c times 2x minus 3, so we've got 2bx squared. We've got 2 c's and minus 3 b's, so it's 2c minus 3b times x. And then we've got minus 3c as the constant term, all divided by the denominator. So for these to be the same, the coefficient of x squared, x, and the constant have to be the same on the left and the right. So the coefficient of x squared on the left is 4. The coefficient over here is, well, there's an a x squared and there's a 2b x squared. So let's write that as a plus 2b. Right, there's the a and there's the 2b. The coefficient of x is on the left is minus 9, and on the right, well, we've got minus 4a, right, minus 4a and 2c minus 3b. And the coefficient of 1, the constant term, on the left here is 5, and now we've got how many constants? We've got 4a, and then for the constant here, we've got minus 3c. Okay, we have to solve these equations. So as usual with partial fractions problems, you end up with some linear algebraic equations to solve. Here we've got 3 unknowns, a, b, and c, and we've got 3 linear equations. So we can solve that by manipulating in one way or another. So one thing we can do, you can easily find yourself going around in circles with these problems. Like, for instance, we could, it looks like maybe adding these two together might make sense. In that case, you'd eliminate the a between these two, but you'd end up with a b's and c's over here, and over here you've got a's and b's. So you haven't actually really eliminated a properly. And anyway, so it ends up to being a bit of a, I tried it. I found out that if you just add these things together, you can find yourself going around in circles. So let's think a little bit more about how we could do that. This top equation has an a and a b in it. These bottom equations have a's and b's and c's. So if we could eliminate c out of these last two equations, we would have just a's and b's, and the top equation has just a's and b's, and then we can make some progress. So if we want to eliminate c, well, one way of doing it is to multiply this number by 3 and this one by 2 and then add. So if I take that top equation times 3, that becomes minus 27 is minus 4a, minus 12a, sorry, minus 12a minus 6c, sorry, plus 6c, and then minus 9b. And if I multiply this one by 2, that will become minus 6c, so this is 10 is 8a minus 6c, and if we're now in a position to add them, but minus 27 and plus 10 is minus 17, and this is minus 12a plus 8a is minus 4a, and the 6c's and the minus 6c's cancel, minus 9b. All right, so the reason for doing that was to take these bottom two equations and manipulate them so that they didn't have a c in them, and the reason was that this top equation didn't have a c in it either. We've now got this top equation that has an a and a b, and this new equation here that has an a and a b. So if we take the top equation and do something to it to simplify things, well, how about multiplying the top equation by 4 and adding them? Because if you do that, the a's will cancel. So I'm going to take that top equation here, and I'm going to do times 4. So that becomes 16 here is this 4a, so there, and 2b times 4 is plus 8b. And now I can add them, and the 16 and the minus 17 add to be minus 1. The a's cancel, and the 8b and the minus 9b is minus 1b. So that gives you b is equal to 1. Having got b, we can work out a. So 4 is a plus 2. So a is equal to 2. And c we can get from here, for example. So a is 2, so 5, and that is 8 minus 3. C will be 1 as well. Okay, so it's worth, at this point, just putting these numbers in to check that everything has worked. So if a is 2 and b is 1, a plus 2b is indeed 4. 4a minus 3c, so that is 8 minus 3, which is indeed 5. And here, this is minus 8 plus 2, which is minus 6, and then minus another 3, which is minus 9. So those three numbers there are correct. They satisfy these equations. And we're now in a position to pop them in up here. So that is 2. And bx plus c, the b is 1, and the c is 1. So we've got this fraction here, 4x squared minus 9x plus 5 divided by this great big denominator is the same as 2 over 2x minus 3 plus x plus 1 divided by x minus 2 squared. And if, for example, you were trying to integrate this, you would then be in a position to make progress with the integral.